Okay, let's start going over multiplication rule. Number one, a box of dinner recipes is partitioned into courses. There are 5 recipes under soup, 7 under main course, and 9 under dessert. How many ways can recipes for a 3-course meal be selected from the box? So the first thing that we need to find out is how many ways can we have soup? Well, there's 5 different soups, so there's 5 possibilities for the first course. How about the main course? There were 7 possibilities under the main course. So we would want to multiply those because we could choose anything from the soup and then anything from the main course. Finally, there were 9 dessert options, and so we would need to multiply that as well. So to do this problem, we would do 5 times 7 times 9, which I get 315. So there are 315 3-course meals here. Okay, number 2, a popular clothing store carries 9 different sizes of shirts, each size in both men's and women's designs, and each is made with either wool, cotton, silk, and each is either knit or woven. How many different kinds of shirts does the store carry? Okay, so there's 9 different sizes, so there's 9 of them. Each size comes in both men's and women's, so that's 2 different genders, so we'll multiply that by 2. Each is made with either wool, cotton, or silk, so there's 3 different materials. Let's multiply by 3. And each is either knit or woven, so 2 different styles, so times 2. So how many different kinds of each shirt? So let's multiply 9 times 2 times 3 times 2. And I get 108. So 108 different shirts. Let's see, the third one. If automobile license plates can have 3 letters followed by 3 digits, and the repetition of digits and letters is allowed, how many different license plates can be made? Okay, so let's see. We have 3 letters first. There are 26 letters, so we'll do 26 times. There's 26 options for the first letter, 26 options for the second letter because we were able to repeat it, and 26 options for the third letter, times, now we have 3 different digits. There are 10 digits that could possibly go for the first one, then 10 and 10, so we're multiplying 26 times 26 times 26 times 10 times 10 times 10, or if you prefer to write it, 26 cubed times 10 cubed. So let's try that. Oh, okay, so here's what I get for my answer right now, but I will check back in a minute. Okay, on the third problem, if automobile license plates are able to have 3 letters followed by 3 digits, the first digit cannot be 0. How many different license plates can be made if you can repeat digits or letters? So let's see, there are 26 different letters, so 26 possibilities for the first letter, 26 possibilities for the second letter because you're allowed repeats, and 26 possibilities for the third letter. In terms of the digits, if you can't include 0 for the first one, then there's only 9 possibilities for the first digit, but then there are 10 possibilities for the second and the third. So 26 times 26 times 26 times 9 times 10 times 10. So I get 15,818,400 different license plates. Okay, so now if we take a look at the bottom, there are 3 red marbles and 2 green marbles in a bag. You pick a marble, record its color, and then put it back in the bag. You pick a second time and record the color. What's the probability of recording 2 reds? I'd like to make a tree diagram for this. So I could either get a red marble or a green marble. the probability of recording 2 reds is what I'm looking for. So the probability that I get a red the first time is 3 out of 5. Because I put it back in the bag, the probability of it being red the second time doesn't change. So the second time I could get a red or a green, but if I'm interested in finding out what's the probability of getting red again, that's 3/5 for the first red and 3/5 for the second red, or 9 out of 25. In example 2, there are 3 red marbles and 2 green marbles. This time, after you pick the first marble, you do not put it back in the bag. So when I go to make my tree diagram, the first time I could get a red or green, and the probability of getting a red the first time is 3/5. But now when I go to pick the second time, there are no longer 5 marbles there, there's only 4 of them. And out of that 4, only 2 of them are still red, so 2/4. So when I multiply my probabilities, I get 6 out of 20. Let's see if these are equivalent. 9 divided by 25 is a 0.36% chance of that occurring. Sorry, a 36% chance. Whereas 6 over 20 is a 30% chance. So the probability does change.